Hello everyone, my name is Vincent and I'm here to demonstrate the sample input and output of these equations by inputting a 3-bit binary sequence and gaining an output in terms of the 7-segment display. So first of all, I have these equations, which is the square root of 1.8 times A plus the square root of 3.3 times B plus 1.9 times C squared, which will gain an output of Z. Then this Z output will be displayed into a 7-segment displays, where the first 7-segment display will always constantly showing a 0, while the other two is varied based on the result of these equations. So first, when we input A, B, C equals to 0, 0, 0, we will get an output of 0. And then when we input 0, 0, 1, we will get an output of 1.9. When we input 0, 1, 0, we will get a 1.8. When we input 0, 1, 1, we will get a 3.7. When we input 1, 0, 0, we will get a 1.3. When the input is 1, 0, 1, we will get an output of 3.2. As well as when we input 1, 1, 0, we will get an output of 3.2. And lastly, the last binary bit sequence is 1, 1, 1, we will get an output of 5.1. By using LabVIEW, we can demonstrate the input and output and mimicking the 7-segment display. So we will try to run and check whether it is matched the logical truth table. So when it is 0, 0, 0, the output is 0. It's the same with the truth table. When 0, 0, 1, we will get an output of 1.9. When we input 0, 1, 0, we will get an output of 1.8. When we input 0, 1, 1, we will get an output of 3.7. When we input 1, 0, 0, we will get a 1.3. When we input 1, 0, 1, we will get an output of 3.2. When we input 1.0, we will get an output of 3.2. And lastly, when we input 1, 1, 1 to the ABC, we will get 5.1. This exactly match the truth table. Let's check. So when it's 0, 0, 0, we will get a 0. When we input a 0, 0, 1, we will get 1.9. When we input 0, 1, 0, we will get 1.8. When we input 0, 1, 1, we will get a 3.7. When we input 1, 0, 0, we will get 1.3. When we input 1, 0, 1, we will get a 3.2. When we input 1, 1, 0, we will get 3.2 as well. And last, when we input 1, 1, 1, we will get 5.1.
Hello, my name is Marvin Oquento with TP078368, and today I will be showing you guys about my digital electronics assignment. So this is the equation that has been given by the lecturer, and I turned it into a truth table. So for the Z, the answer is this, which I should turn it into a wiring method. And this is the wiring. It's a bit messy. Yes. And for the output, it's according to the Z that I've calculated it. So for example, if 001, it gives like 0.6, which is similar, right? See, the 001 is 0.6. And then 010 is 4.9. Yes, it's 4.9. 011 is 5.5. Also similar, 5.5. And then 100, it gives 0.9. Also, which is also 0.9. And then 010 is also the same, 1.5. 110 is 5.8. And 111 is 6.4.
Okay, hello everyone. So in this video, I'm gonna explain on how my work's gonna work. Okay. Okay, let me open the view first. So here you guys can see three equations. I wrote it A, B, and C, same on here in the table as you guys can see, A, B, C. Okay, so how it's gonna work is basically, as we can see here, okay, let's moving on the first table is 0, 0, 0, of course it's gonna equal 0. Okay. Also, I counted in my equation, so yeah. This is the equation result is Z is the equation result. So yeah, moving on the next one, the second one in the table is 0, 0, 1. So how it's gonna work is if I put here so if I on this basically we just count it once, so it's 0, it's gonna be 0, 0, 1. So the result is 0.1. As you can see here, it's gonna be 1.1, sorry. 1.1. The result is 1.1, and here's gonna be 1.1. Okay, moving on the third one is 0, 1, 0. So we're gonna turn this on. As you can see, it's 1.6. Next, moving on to the next one. Okay, 0, 1, 1. So it's gonna be 2.7. Okay, moving on to the next one is gonna be 1, 0, 0. So just turn this off. It's gonna be 0.8. 0.8. Okay. Next one is gonna be 1, 0, 1 is gonna be 1.9, and next one 1, 1, 0 is gonna be 2.4, and last but not least is 1, 1, 1. So basically everything, turn it on, and it's gonna be 3.5. Okay, so as we can see, the number is followed by the result from the equations from each part. Like 0, 0, 1 is equal 1.1, 0, 1, 0 is equal 1.6. So, yep, that's basically how it works. So, how I get Z? Z is from my calculation from this formula. Okay, so basically that's how I get Z. So yeah, basically that's all from me. Um, simple things to do, easy, not difficult, but yep. So yeah, that's all from me. Bye bye. Thank you so much for watching. Love you.
This is Richard Sationo, TP number 082095, and today I'm gonna show you the simulation of the DE assignment of my equation inside an application called LabVIEW. So we can see that in the front panel, I put three buttons which are representing the input binary of the truth table. And then we also use 7-segment displays to display the outputs of the corresponding Z values. And then for the block diagram, we use AND block and also OR block based on the equation that we calculated earlier, the Carnot map. Let's see when the simulation is running. When it's running, we can modify the A, B, C buttons, and then it will the 7-segment displays will show the output of the right Z values. Let's see. For 0, 0, 0, it shows 0. For 0, 0, 1, it shows 0.4. And for 0, 1, 0, it shows 2.7. For 0, 1, 0, for 0, 1, 1, it shows 3.1. And then 1, 0, 0, it shows 5. And then 101, 5.4, 110, 7.7, and 111 is 8.1. So all the Z values and the are shown correctly, which means that the simulation is running properly and correctly, and then we can use it for the assignment. All right, that's all. Thank you.
Hello, Miss Eva. My name is Dennis. from CE, and my TP number is TP081345, and I would like to demonstrate my output of the logic. So this is for my output signal, which is C, which is 001. It shows the 15, which is correct with the equation solved. Changing the BC, changing to B, which is correct, to 19, which is root 37 is root 3.7 is a 1.9, which is correct. And the A is a root 4, which is 2. It's the exact same solve with the equation. So as well the others. A to C is 35, then AB, which is 39, and then on everything, which is total is a 5.4, which is correct with all the same solve the equation. Thank you.
Hi everyone, my name is Brandon Go, TP078137, and today I'm going to present my logic circuit here. So I got an equation which is the cube root of 3a plus 3b squared plus cube root of 4.6c, which is all equals to z. Okay, so from this equation, I got that z, if ABC 001 is 1.6, 010 is 3.4, 011 is 5.0, 100 is 1.4, 101 is 3.1, and 110 is 4.8, and lastly 111 is 6.5. So how do I get this z value? We just need to substitute the value of all of these ABCs into the equation, as simple as that. Okay, so from here, 1.6, we can test in the logic circuit here. Run it. If all of 3 is 0, which is off, 0, 0, 0, then the z value will be 0. As shown here, it's 0, right? Everything is 0. If it's ABC, if it's 001, through only on the C, it will show 1.6, as you can see here. If it's 010, 3.4, 3, and 4. If it's 011, 5.0. If it's 100, it's going to show 1.4, 1, 4. 101, 3.1, 3 and 1. 110, 4.8, it's 4 and 8. And lastly, 111 is 6.5, 6.5 as shown here. So this shows that the logic circuit is working perfectly fine with every possible ABC values and Z values from the equation shown at the 7-segment indicator. So that's all from my project. Thank you very much.
Okay, hello, my name is Jerry, and for my DE equation, I was assigned with this 2.2a squared plus cube root of 3.9b plus 1.c cubed. So for the first input of A0, B0, and C0, the Z output is expected to be 0. So in the program, this should display as 0, 0.0. Okay. Then next for inputs A0, B0, and C1, this is the Z is calculated to be 1.2. And if we run 1.2. Okay, next for ABC 010, Z is calculated to be 1.6. And if we put in the values and run here 0, 1.6. Next for ABC 011, Z is calculated to be 2.8. And if we put in and run, 0, 2.8. Next, 100, this is output 2.2. And if we run, yep, 2.2. Next, ABC of 101. This is calculated to be 3.4. And if we run, yeah. Then next 110. The Z value here should be 3.8. And if we run, yeah, it displays 0, 3.8. And finally, ABC of 111. This is calculated to be Z equals 5.0. And if we run here, it should display 0, 5.0. Okay, that is all. Thank you.
So after creating the logic circuit for the 7 equations, now we are going to integrate those 7 equations into one big circuit, which allows the user to select one equation at a time. So we can do that by implementing the concept of decoder and multiplexer. So decoder will help us to select one equations out of the 7 equations, and multiplexer will help us to sort out the output from the 7 equations that match with the equation that is being used. So we have two 3-bit binary sequence, which is ABC and DEF. ABC is the input to the equations, which later give us the result of the equations, and DEF will be the input to select the equations that we want to choose. So there are 7 equations and there are 3-bit binary, so it means that there will be a total of 8 combinations, but in this case we only have 7 equations, so the last will constantly showing 0 because there is no equation. So we will run. So the first equation is square root 1.8 times a plus square root 3.3b plus 1.9 c squared equals to z. So we can select that by inputting 0, 0, 0 for the DEF, and then now we can vary the ABC. So when ABC is 0, 0, 0, we'll get 0. 0, 0, 1 will give us 1.9. 0, 1, 0 will give us 1.8. 0, 1, 1 will give us 3.7. 1, 0, 0 will give us 1.3. 1, 0, 1 will give us 3.2. 1, 1, 0 will give us 3.2 as well. And 1, 1, 1 will give us 5.1. Then we will select the next equation by inputting the DEF equals to 0, 0, 1. Input 0, 0, 0 to the ABC will give us 0, 0. And then 0, 0, 1 will give us 0.6. 0, 1, 0 will give us 4.9. 0, 1, 1 will give us 5.5. 1, 0, 0 will give us 0.9. 1, 0, 1 will give us 1.5. 1, 1, 0 will give us 5.8. And 1, 1, 1 will give us 6.4. To select the next equation, we will put the DEF into 0, 1, 0. Then now we can vary the ABC. 0, 0, 0 will give us 0. 0, 0, 1 will give us 1.2. 0, 1, 0 will give us 1.6. 0, 1, 1 will give us 2.8. 1, 0, 0 will give us 2.2. 1, 0, 1 will give us 3.4. 1, 1, 0 will give us 3.8. And 1, 1, 1 will give us 5. And then to select the next equation, we will input the DEF into 0, 1, 1. Then 0, 0, 0 will give us 0. 0, 0, 1 will give us 0.4. 0, 1, 0 will give us 2.7. 0, 1, 1 will give us 3.1. 1, 0, 0 will give us 5.0. 1, 0, 1 will give us 5.4. 1, 1, 0 will give us 7.7. And last 1, 1, 1 will give us 3.1. Then the next equation we will input DEF equals to 1, 0, 0. The input ABC 0, 0, 0 will give us 0. 0, 0, 1 will give us 1.6. 0, 1, 0 will give us 3.4. 0, 1, 1 will give us 5. 1, 0, 0 will give us 1.4. 1, 0, 1 will give us 3.1. 1, 1, 0 will give us 4.8. And 1, 1, 1 will give us 6.5. And next equation is 1, 0, 1. And then 0 input 0, 0, 0 will give us 0. 0, 0, 1 will give us 1.5. 010 will give us 1.9. 011 will give us 3.4. 100 will give us 2. 101 will give us 3.5. 110 will give us 3.9. And lastly, 111 will give us 5.4. Then the last equation is 110 to the DEF. Then input 000 to the ABC will give us 0. 001 will give us 1.1. 010 will give us 1.6. 011 will give us 2.7. 100 will give us 0.8. 101 will give us 1.9. 110 will give us 2.4. And last 111 will give us 3.5. And for the eighth combination of the DEF, which is 111, there is no equation. As we can see, equation in use is strict. So for the whole ABC combination will be constantly showing 0. So let's see. 00 will give us 0. 001 will give us 0. 010 will give us 0. 011 will give us 0. 100 will give us 0. 101 will also give us 0. 110 will give us 0. And last 111 will give us 0. So that's all. Thank you.